Okay, so what did I ask you to do? What did you try to do?
So it was the Kernow questions and the proportional Russian by the end.
Where were the Kernow questions?
Yeah. There you go.
I guess I should turn it around a bit so it's more. Maybe it's an adverse consequence of having the video here that people realise they don't need to bother turning up.
We'll check the number of views. That'd be easy.
I can't imagine it's very fun watching these videos. Okay, so how far did you go?
I think I might have the equation for the number of firms, but I'm not convinced.
I think I know what you were supposed to do, but I couldn't get anything sensible.
Okay. Well let's go from the start. So the first bit is like we did last week. Okay, so Q of P is 1 minus P. So profit price times quantity at that price. Oh, this is corner. Yeah. Okay. So let's make our life easier to start with. Okay. Let's invert the demand curve. So Q of P is 1 minus P. So P of Q is 1 minus Q. Okay. That makes life a bit easier. Okay. So the profits of firm I. So we're going to use this demand curve. It's the quantity produced just by firm I times the price at which that firm can sell. Do we have? Does it say anything about costs?
We either assumed that there was marginal cost or no marginal cost. Either constant or zero. I can't remember what we assumed at the beginning.
As a function of C and F, okay, it's just a constant. I didn't really say that. But it's, okay, so C times QI. Okay, constant marginal cost. Right, so there's profits of firm I, normal thing, first order condition, D pi I, D QI. Okay, partial. So we're going to use the product rule as normal, so the derivative of this is 1 times that, so P of Q times plus QI, okay, times the derivative of this with respect to QI. Okay, so P of Q is 1 minus Q, so look, D, P big Q, D little q, okay, that's D, P big Q, D big Q times D big Q, D little q. Okay, so big Q is just the sum of all the little q's. Okay, so this is 1, D big Q, D little q, and dP of Q, dP big Q, dQ is just minus 1. Okay, so the derivative of this with respect to little q is just minus 1. Okay, minus for this thing, so derivative of that is okay. Tell me if I make a mistake. Okay, so let's write this a bit neater. So this is 1 minus big Q minus little q minus c. So the trick is the same trick as always. You have to add across all of the n firms. Okay, so if we add up, we get naught is n minus nq minus big Q minus nc. Is that clear? So you know, we've got n copies of 1, n copies of q. When you add up all the little qi's, you get the big Q. And when you add up all the c's, you get n times c. And then it normally helps to divide by n. Okay, so naught is 1 minus big Q minus 1 over n big Q minus C. So we want to put all the Q's over to the other side. Okay, so we've got one Q there, we've got 1 over n Q's here. So Q times 1 plus 1 over n is this minus that, 1 minus C. So big Q is 1 minus C over 1 over n. Okay, then we can substitute that back in to find the price. Okay, so price is just 1 minus big Q, so price is going to be 1 minus all of this, 1 minus C, 1 plus 1 over n. You know, to simplify this, we write 1 plus 1 over n as 1 is equal to 1 plus 1 over n divided by 1 plus 1 over n, right? Minus 1 minus C. Okay. Have I made a mistake somewhere?
I don't think so.
You don't think so? Okay, so these are going to cancel. 1 minus 1, so you get 1 over n minus C over 1 plus 1 over n. Which doesn't look
Plus C, sure.
plus C. Minus makes a plus, that looks better. Okay, so let's just do a sanity check. As n goes to infinity, this 1 over n is going to 0. So you've got 0, 0, so price is going to marginal cost as the number of firms goes to infinity. So that looks vaguely plausible. Let me just check again. Yeah, that's fine, isn't it? We've got the formula in the other week, so I'll just double check. Okay, so the general formula I gave last week was Q is P naught, which here is 1 minus 1 minus marginal cost, C1, 1 minus C over 1 plus 1 over n, 1 plus 1 over n times P1. Okay, here's 1. That was just from subbing in the general formula we had last week. Okay, so it's right. Don't know why I was paranoid there. Okay, so look, we've got quantity and price. The free entry condition, remember, says that the profits you make after you enter should be equal to the cost of entry. Okay, so here's our expression for profits a firm's going to make. Okay, it's for quantity they're producing times the price of that quantity minus cost, or you can rewrite that as quantity they're producing times price minus marginal cost. Okay. So this is big Q.
Does the profit function need fixed costs in it? Yeah.
So this is kind of the profits from the production period. So overall profits would have fixed cost in, but it's easier to work with the profits just from the production period. So we know what big Q is. What's little q going to be?
Divided by n.
Yeah, exactly. So qi for all I is going to be 1 over n times all of s, 1 minus c over 1 plus 1. Okay, so we've got qi. So we want to know qi times price minus marginal cost. Okay, so profits of firm I are going to be this thing, 1 over n, 1 minus c over 1 plus 1 over n. times price, which we worked out here. So 1 over n plus c over n plus 1 over n minus marginal cost, which is c. Okay. This is a bit messy, isn't it? Can we simplify a bit? I guess we can. Okay, to rub out. So let's just simplify profits a bit. This thing in brackets we can simplify, and we can multiply out a little bit. So hopefully we can simplify. So we can take this 1 over n onto the top here. So it's 1 over n minus c over n. Okay. Divided by 1 plus 1 over n, divided by 1 plus 1 over n, all times this bit, okay, which is 1 over n plus c over 1 plus 1 over n minus c, which we're going to write as c plus c over n divided by 1 plus 1 over n. Okay, so c plus c over n divided by 1 plus 1 over n. You can see that this thing is equal to c. It's the normal trick for working with fractions, right? You want to get the bottoms to be the same. And then this is going to simplify a bit more. We've got a plus c there, we've got a minus c there. That's going to cancel. So this is going to be 1 over n minus c over n, all divided by 1 plus 1 over n. What we've got here is 1 over n minus c over n, all divided by 1 plus 1 over n. So it's going to be this thing squared. And in fact, we can simplify this a bit by multiplying top and bottom by n. Okay, so if you multiply top and bottom by n, you're going to get 1 minus c over 1 plus n, all squared. So it's slightly annoying algebraic manipulation, but it's not difficult. It's just tedious, right? Maybe it's difficult. You know, it's what you always do when you've got a fraction like this. You express this as something divided by this thing, and then you can simplify the fraction, and you carry on simplifying. Okay, and then the free entry condition says this thing should be equal to the fixed cost. So we've got a squared there, so let's take a square root of both sides. So 1 minus c over 1 plus n is equal to the square root of the fixed cost. Multiply both sides by 1 plus n, so 1 minus c is equal to root f plus n root f. And then subtract root f and divide by root f, and you're going to get n is 1 minus c minus root f, all divided by root f. Have I made a mistake? Are you confused?
Where's the, because it's the prime function, where's the cost times quantity? Because that's quantity, that's price, and you translate to 1 minus c over 1 plus n squared. Then where's the minus c times q? Like,
So we did, what we had was, we wrote it in this way. We did pi I is
yeah.
quantity produced times price minus marginal cost,
Oh, right.
because it's constant marginal cost. So this was for price term, and this was marginal cost.
Yeah, okay.
Okay. Okay, so it's a bit of a long question, but, so you can get to a number of firms. Social welfare, what does that, is a bit of a tricky question. It's a bit too hard for an exam, I expect. So we had an expression for social welfare which we can probably use. Okay, let me put the whiteboard up so I can write on my main board. Okay, so we've got a demand curve that looks like this, right? That's one, that's one. This is quantity, this is price. We've got some constant marginal cost of C. And some quantity Q star is being produced. Okay. So total surplus is that area. Half of that will be consumed surplus. So what's the area of that? What is it? Trapezium? I don't know. We did all this in GCSE maths, but that was a long time ago. So the area of that shape. Well, you can do it in two. You can do it this way. If that makes it easy.
So for the triangle, it's half Q times 1 minus C.
So for the triangle, well, the triangle. So this is 45 degrees again.
Oh yeah.
Because so this length is that length is also Q star.
Yep.
Okay. So the triangle is going to be half Q star squared. And the square, well, it's not a square. So this distance is Q star. If its whole distance is 1 minus C, and you've taken away a distance of Q star, so you've got 1 minus C minus Q star. Yeah. So that's Q star times 1 minus C minus Q star. And then, you know, you could substitute in if you could be bothered. Okay. So maybe we can. It's not going to give you a very nice answer, is it? Just thinking. Maybe I should put some numbers to this, and then it would be easy. I think in next week's lecture. Okay, well let's look. Let's make our life a bit easier, because this general case with marginal cost is certainly too hard for an exam question. We've got so far with marginal costs. Let's just make our life easier now. So let's go to the case in which C is 0. Okay. And then everything's gonna get a lot easier. So Q star is 1 over 1 plus 1 over n. N, is that what I had before? Okay, so n is going to be 1 minus root f over root f. So look, Q is 1 over 1 plus n. 1 over 1 plus 1 over n. But n is this thing, 1 minus root f over root f. 1 minus root f over root f. So that's the quantity that was being produced at the optimal number of firms. We're just substituting in. And you can simplify this. So you've got division on the bottom of a fraction, that's just the same as multiplication on the top of a fraction. So that's 1 over 1 plus root f over 1 minus root f. And in fact, you can simplify a bit more. Let's multiply top and bottom by 1 minus root f to get rid of that. So you get 1 minus root f times, you're going to get 1 minus root f here, and then you're going to get a plus root f, so the minus and the plus cancel, and you just get a 1 on the bottom. So the optimal quantity is 1 minus root f. I should have said c equals 0 in the question. It was too hard at first. So does that make sense? So the higher fixed cost, the lower quantity is. That makes sense. With lots of high fixed costs, you get little entry, so you get less gets produced. So it kind of meets a minimal plausibility criterion. So let's now plug that into this social welfare thing. So social welfare is going to be equal to half times 1 minus root f squared plus 1 minus root f times 1 minus q, which is just root f. And you can multiply out the brackets a bit, I suppose. So here, this is going to be half minus root f plus half f. Is that right? And then here we get plus root f minus f. Okay. These two cancel. We've got minus a half, and we've got a minus 1 and plus a half, so that's the same as minus a half. So it's half times 1 minus f. So with fixed costs of 0, welfare, the smaller fixed costs are, the higher welfare is. That makes sense. With fixed costs of 0, you know, you get the perfectly competitive outcome, right? People enter until profits are driven down to 0. And if you look at the perfectly competitive case, welfare is going to be this whole triangle. Okay, and so we've set c to 0 actually, so it's this whole triangle, which has a base of 1, a height of 1, so it's going to be welfare of a half. Okay, so that's making sense. Okay, so this was welfare with the number of firms that would enter under free entry, and then the question asked for the socially optimal amount of entry. So oh shit, I've done something wrong. Sorry guys. We've forgotten a term from welfare. So sorry about that. I'm half asleep. So yeah, you know, this welfare calculation is telling you the consumer surplus and the producer surplus, but then there's this extra loss that's coming from paying fixed costs, which is just pure waste. You know, you can think of it as these fixed costs being like a tax on consumers or something, so they've got to come out somewhere. So we're gonna get an extra term on the end of welfare. Okay, minus NF everywhere. Minus NF, minus NF, minus NF. Okay, but just as before, when f is 0, the last term is going to drop out. And in fact, we know what n is, don't we? We know n is 1 minus root f over root f, so we can substitute that in. So half 1 minus f times 1 minus root f. So we've got a division by root f on the bottom. We've got a times by f on the top. So f divided by root f is just root f. So this is going to be minus root f times 1 minus root f. Sorry. That's what we had up there even. So it's just going to be this expression. Sorry, if I'd done it right to start with, we would have saved ourselves some time. Now let me write it again, so it's clear what we're doing. Okay, so we said welfare was half q star, which came out as 1 minus root f. Okay, so it's half 1 minus root f squared. This expression plus q star times 1 minus q star. Okay, so q star again was here 1 minus root f. So 1 minus root f times 1 minus that, which is just root f, minus n times f. Okay, n we've got written down here. Okay, so this is 1 minus root f over root f. Times n, so that's n, and then we need n times f. N times f. Okay, here we've got f over root f. That's just the same as root f. So this term and that term just cancel out. Okay, so the welfare is half 1 minus root f squared. Sorry, I'm stupid. Okay, so the next thing we were supposed to do was the socially optimal level of welfare. So here's the general expression for welfare, right? Including that minus nf term. And q star is this function of the number of firms, okay? So we're going to be choosing the number of firms in order to maximize social welfare. So, the firms are free to set what quantity they want once they've entered, but the social planner is deciding how many firms are entering. Okay, so again, we're plugging this expression in there. Okay, so in this case we get W is half times, here's q star, so 1 over 1 plus 1 over n. 1 over 1 plus 1 over n, all squared, plus q star, same thing again, 1 over 1 plus 1 over n, times 1 minus q star, so 1 minus 1 over 1 plus 1 over n, and then this last bit, minus n times f. So this thing here we can simplify. So this is going to be, you can think of 1 as 1 plus 1 over n divided by 1 plus 1 over n. Okay. So when you subtract 1 from that, you get 1 over n divided by 1 plus 1 over n. Okay, so this is going to be half 1 over 1 plus. And now let's make these. No, I'll leave it here. Half 1 plus 1 over n, all squared, plus what we had before, 1 over 1 plus 1 over n, times 1 over n over 1 plus 1 over n. Yeah, so these are probably trickier exercises than you'd ever get in an exam, but the point is that if you can do exercises like this, then you can certainly do the exam questions, you know, so it's good to start with the hard ones, I think. So, it's a pain, isn't it? So, like this thing here, let's take this 1 over n outside, okay? So we've got a 1 over n on the top here, let's put it there. Okay, then those two things are the same. So this is half plus 1 over n times 1 plus 1 over 1 plus 1 over n, all squared, minus n times f. Something gone wrong?
So I'm just confused. Where'd you get the one? Where have you taken the 1
So-
over n from?
So there was one here.
Yep.
We took it out there. Okay.
Okay.
So this is 1 over 1 plus 1 over 1 plus 1 over n times 1 over 1 plus 1 over n. So that's just 1 over
Okay,
1
so
plus
it's just-
squared. Okay. So this thing here is the same as that.
Cool.
So we can go collect the things. At some point we have to differentiate this, and I guess we've got to that point. I can't make my life any easier. So no, it's not really nothing you can do to help really. So okay, the social planner is choosing the number of firms. Okay, so we're going to maximise with respect to the number of firms. Let me go to this board. Well, you can just use the product rule here. So derivative of this bit is this term in the brackets. Please, what's the derivative of all of this?
Over n squared?
Yeah, minus 1 over n squared.
Yeah.
Okay, so we're doing the derivative of this times that plus this times the derivative of that. Okay, so here to start with we get minus 1 over n squared. Okay. Times what we had before, 1 over 1 plus 1 over n, all squared. Okay, the next term is this times the derivative of all of this, plus half plus 1 over n. I thought this had a nice answer. Okay, so the derivative of all of this, well, we can use the chain rule on it, something squared. So it's going to be 2 times all of this times the derivative of the inside, just using the chain rule. So we're going to get a 2 in the front and 1 over 1 plus 1 over n. Okay, then we have derivative of the inside, which is derivative of this fraction with respect to n. What's that derivative? A bit harder. You can use the chain rule again if you want. So you can apply the chain rule to 1 over this thing.
So like minus n over 1 plus n squared.
Minus minus sine over 1 plus n squared. That sounds plausible. So, how did you get there? So, go on, show me how you got there on the board.
Oh, okay.
Oh, so you're doing u dash v minus v dash u over v squared.
Oh,
Okay.
I ended up that wrong.
So u dash no, it looks fine. So here's the derivative of the top is 0. No one can just stand to one side a little bit so we can say derivative of the top is 0. There's the bottom. So that's u dash v, and then we've got minus top times the derivative of the bottom. So what's
Minus n over n squared. No, minus 1 over n squared.
yeah, exactly. Yeah, all over that bottom squared. Yep. So you've got a minus sign, that's a 0, so that just drops out. You've got a minus sign and a minus sign, so that becomes a plus.
N squared.
Okay. Yeah, so what we were doing the product rule to this thing, so we did the derivative of that times all of this, and then we did this times the derivative of this, okay, and we split this in two. We treated this using the chain rule, so we did the derivative of x squared, where x is this bit, times the derivative of the inside. Okay, so now we've worked out that the derivative of the inside is this thing there. I really remembered this having a nice answer, but it doesn't look very nice, does it? 1 over n squared over 1 plus 1 over n squared. Okay, so that's the derivative of all of this, and then we just have a minus f at the end. Hopefully we can simplify this. So let's take a 1 over n squared out. Okay. And let's take f over to the other side, okay? So we've got f is equal to something. First term was minus 1 over n squared times 1 over 1 squared. And then we're taking this 1 over n squared out, okay? So we've got 2 over n squared times half plus 1 over n. All times 1 over 1 plus 1 over n cubed. Okay, we've got 1 from there, we've got 2 from here. So
Sorry, what did you keep?
1 plus 1 over n.
Oh, yeah, cool.
Because this squaring of the bottom is the same as
Yep,
you know, once you've taken this outside, squaring the bottom is the same as squaring the
Sorry,
bottom.
it was just that it was outside the bracket, which sort of threw me a little bit. Which makes sense. No, I followed it, yeah.
What was the question we're answering?
Fair point. We're working out the socially optimal level of welfare. So the socially optimal number of firms. So we're choosing n to maximise social welfare. And there's, I think, just trying to see where I haven't made a mistake somewhere. Okay, so um, so we've got 1 over 1 plus 1 over n squared here. We've got 3 copies here. Okay, so let's just divide through everywhere by this thing. Take all that over to the other side. Okay, so f divided by 1 over 1 plus 1 over n all squared. Okay, is equal to minus 1 over n squared plus, and we're going to multiply out all these brackets now, so 2 over n squared times a half is just 1 over n squared. 2 over n squared times 1 over n is 2 over n cubed. Okay, and then this is all times what we had left, which was 1 over 1 plus 1 over n. And then let's get rid of all the n squareds as well. Let's multiply both sides by n squared. Take all the n squareds over to the other side, and we can simplify this because we can put that up to the top. So f times 1 plus 1 over n all squared times n squared. Okay, is minus 1 plus 1 plus 2 over n times 1 over 1 plus 1 over n. Okay, we're getting somewhere finally. I really hope this simplifies, otherwise this is a complete waste of time. So let's put that minus 1, let's treat it as minus 1 minus 1 over n over 1 plus 1 over n.
Tom, I'm a bit confused. How have you managed to take the f over 1 over 1 plus 1 over n to all squared and make it just 1 plus 1 over n squared rather than to the minus 2?
So here we had f divided by this thing.
Mm-hmm.
Okay, so that's the same as f
F over
so-
1 plus 1 over n.
yeah, so look, you can think of this as f times all of this to the power of minus 2.
Yeah.
Okay? You can think of this as that to the power of minus 1. Okay, it's the minus minus. God, is it 2? God. How's this taken so long?
No, it's only 1.
Black clock's
They
wrong.
didn't change it.
Hour earlier.
But your thing is at 1.
My thing's at, the thing's at 1.
Sorry guys, maybe I should have another class this afternoon. Yeah, so you see, so you've got division on the bottom is the
Yep.
same as multiplication on the top. That's all you're doing.
Ah, okay. So you're treating it as two fractions.
Yeah.
So you're treating it as f over 1 times 1
Yeah.
over 1 plus n.
Yeah, so you can think of
Ah, okay.
yeah. This is in brackets.
Cool.
The same thing. Come on, let's just whack through this. Okay, so then on the top we get plus 1 plus 2 over n. Okay, minus 1 and the plus 1 cancel. 2 over n minus 1 over n is just 1 over n. Okay, this is going to work. 1 over n over 1 plus 1 over n. We've got a 1 plus 1 over n here, let's take it over. Okay, so finally, I know it's you know, it's good practice, even if. Okay, and then we've got an n there, so we can take that over, times n cubed is equal to 1, which is a lot simpler. You can take the n into the fraction even, so this is f times 1 plus n cubed equals 1. So divide both sides by f and then take the cube root. Okay, so 1 plus n is equal to 1 over the cube root of f. Okay, so n is equal to 1 over the cube root of n minus 1. Okay, whereas under the under laissez-faire we had something with square roots. You know, you can write this as root f over root f is just 1. Okay, so you can write that as what n is 1 over the square root of f minus 1. Okay, so that was under laissez-faire. This was the social optimum. Okay, it's horrible, I know, but the point is to go through the. You know, people didn't believe me that there were too many firms entering. Okay, and if you go through all of this, you get a definite answer for the number of firms in the 2 case. And now it's completely clear. You know that the cube root of f has to be, okay, the cube root of f would be bigger than f because f has to be between 0 and 1. Okay, so this thing has to be smaller. Okay.
Yep.
It's horrible, but it's a useful exercise, right? You know, I know it's too hard to go through an exam, but seeing how this works is good again.
Next level algebra.
You know, it's not difficult. It's no. You think it is difficult?
I'm
It's
still,
just tedious,
I'm
isn't
still a bit lost with that. I'd need to work through it myself just to make sure I fully understand that,
But
that bit with the
it's the simple steps that you've seen, you know, 1,000 times. Okay, just chaining them one after another. I was quite scared for a while there, but I wasn't going to get what we were supposed to be getting. The Krebs-Schenkman exercises we can look at another time, I guess.